All right, here we go. Here we go. Okay, please look and let's take a look up here.
Guys, is that not done with you?
All right, so here's the last section that we're covering is nothing new. It's just applications of quadratics. There's tons of applications of quadratics in physics and, I mean, all kinds of things. Lots of situations can be modeled with a quadratic function or a quadratic equation. So what about one like this? Tells us that the width of a rectangle is 6 meters less than its length. Find the area of the rectangle, or find the dimensions if the area is 112 square meters. Okay? How are we going to do this? These would have been fun for a competition. That's all right.
Oh my goodness.
I like competition.
L minus 6.
Okay, so
Wait, so then would you do 112 minus 6? Which one? And then unsquared.
okay, so we want a rectangle, right?
See?
What are the dimensions of the rectangle?
Well, the area is 112.
X by
Yeah, 112.
Okay.
It's L minus 6 squared.
Okay. So you're gonna get, so if I wanna, here's my picture of my rectangle. It's all, and you're gonna do a lot of this in calculus in a couple of years. Alright, so a lot of this kind of thing, oh yeah, I know, I'm sure you're pretty excited about this. So you wanna make sure you draw a picture always if you can. Because it's easy to label a picture and you can kind of see things visually. So, oops. Okay, so the dimensions here. Let's pick an easy variable. Instead of L's and things, let's just call it X. Right? If the width is 6 meters less than the length, what are we going to call the dimensions then again? Say it again.
X.
X and,
X minus 6.
okay, so we'd say that the length is X and the width would be X minus 6
You did this in algebra.
and the area is 112. I'll give you some harder ones too.
No thanks.
So the area is 112, and so then how do we set up an equation?
You do 4x
Okay.
12.
So X times X minus 6 is the area, which must be 112, right? Okay, so can you see already here that you're going to get a quadratic equation from this?
Yes.
No.
Right? And here's why I want you to kind of think about, when you always want to be very forward thinking when you're doing math. From this point forward in your math careers, you always kind of want to try to map a route to an answer. If I were to distribute the x, I'm going to get x squareds, aren't I?
Yeah.
Just one.
And I've got an equation, right? That's a quadratic equation. Yes, ma'am.
Why wouldn't you just do 4x minus 12 equals 112? If it's the area. Oh wait, no, it's 2x. Oh,
Are you thinking, you're thinking perimeter maybe?
no, that would be the 4x. But if you did 2x minus 6, would that work instead of x squared?
You're, okay, yeah, but it's not 2x.
No, I see it, I see it.
You see what I'm saying? When we distribute, we're setting this up from the rectangle that we built. Now we're just going to move into algebra mode, right? Everything we did here was in geometry mode. Now we move into algebra mode and we're going to solve this thing. Well, what do we do to solve it? We got to simplify, right? So we're going to distribute the x. We're going to get x squared minus 6x equals 112. Now what?
Complete the square.
We could complete the square. It's already set up to complete the square, couldn't we? We could do that. So we're going to get x squared minus 6x plus what on both sides?
Plus
9, okay,
Wait, how'd you get that? Oh, half of b.
right? Half of b squared, that's a good way to do it. And then what am I going to get when I factor on the left side?
9. X minus 3.
Okay, x minus 3 squared equals 121, okay? What's the, now what? Okay, good, I completed the square, now I'm just isolating x, right? So I'd square root both sides.
Wait, would you do minus 9 or plus 9?
Plus 9, because negative 3 squared is positive 9. And I'll make a note of that. The way we got this was negative 3 squared, right? Okay? So if I square root both sides,
Is that 11?
I'd get x minus 3 equals
11.
Plus or minus.
plus or minus
My bad.
11, and then the last step would be to add 3, right?
Yep.
So I'd get x equals 3 plus or minus 11. So I get two answers. I get x equals 14 or x equals negative 8, right?
No.
No?
Oh, that handwriting looks good though on my paper.
No.
Yeah, one of those is not really a valid answer.
Oh, the negative one.
Yeah, why is the negative one no good?
Can't have a negative.
You can't have negative length, can you? In geometry, you're talking about an actual geometric object. You can't have negative length. So we have to discard that one because it's not a geometrical answer, is it? Or geometric answer. Okay. So we only get one answer, which is x, but even that's not our answer. Because our answer wanted to know what the dimensions are. So what are the dimensions then?
14 and 8.
So yeah, so we get 14, this one's gonna be 14, and this one's gonna be 8, right? If I evaluate each of those dimensions when x equals 14. Okay, make sense?
Yes.
So 14 meters by 8 meters. Okay, let's try another one.
Wait, what? Oh,
Wasn't a dream.
Okay, make sense?
I need another one.
Okay, let's try another one.
Oh, not a triangle.
Okay, let's do this. Okay, try this. See if you can set this one up.
The hypotenuse.
Isn't it a squared
The
plus
hypotenuse
c
is a
squared?
long set, right?
Wait, so
Alright,
we're,
yes.
so we're assuming this is a long
So that's, we can assume that because the hypotenuse is something that is specific to a right triangle. Right.
Alright, what they
Come
teach
on,
in Texas is
George.
how to wipe your butt.
Okay, so,
Whoa, this is confusing.
okay, so draw a picture.
I thought I left geometry.
How
No.
is this light so perfect?
I'm just really good at drawing lines, Jim.
Lots of practice, I
You watch some line move too.
Yeah, did you?
Crazy stuff like that.
Okay, so what about this then? What can we say?
The shorter leg.
It's got a 90-degree angle. You can use the Pythagorean theorem.
Okay,
Oh, wait.
the hypotenuse is one more than twice the shorter leg. The longer leg is 7 feet longer than the shorter leg. So what are the dimensions gonna be then? Okay, good. Now, that's something we wanna, you kinda take that for granted, but you saw something important there. Notice that both of the other two legs reference the shorter leg, right? We're not giving anything specific about the shorter leg. So doesn't that need to be x, right? So there's x. The longer leg is 7 feet more than the shorter leg, so that's just giving us x plus 7, good. And what's the hypotenuse?
2x plus 1.
Okay,
Huh?
Oh,
Where did we get that?
From
Oh,
the writing.
oh, 2s.
okay. So how could we, what are we gonna do with this?
Combine.
A squared plus b squared equals
Courtney, what's it gonna be?
2x plus 1
2x.
2x plus 1 equals, say it again?
Plus x?
No, what's the relationship among the sides in a right triangle?
A squared plus b squared
Oh.
equals
C squared. Okay, so, and more generally, leg squared plus leg squared equals hypotenuse squared, right?
yeah.
How bad?
Okay, so we could say that x squared plus what?
X plus 7 squared?
Okay, x plus 7 quantity squared equals 2x plus 1 quantity squared.
Oh, wait.
Okay, now, can you see that this is gonna be a quadratic equation,
Yeah.
right? When I expand all this out, aren't I gonna get x squareds there? And I'm gonna get x squareds there. And when I combine all the like terms, aren't I just gonna get x squareds, right? X squareds and x's and numbers probably, right? So if I square out x plus 7, now let's use our trick let's use our expansion that we don't technically learn until next unit, but you guys are ready for this. You've probably seen this before. A plus b squared equals what if I expand it out, you know? A squared plus
AB, 2AB
2ab.
plus B squared.
Okay, so let's just use that to expand these out. So I'm gonna get x squared plus, what's this gonna give me? X squared plus 2ab is 14x, right?
Yeah.
Plus 49, right? Because that's my a and that's my b, right? If I do a plus b quantity squared, I get a squared plus 2ab plus b squared.
You gotta like visualize a line separate.
Okay?
Breaking it up into 3 parts.
Okay, so now what about this guy here? What's 2x squared? Okay, good. So 2x quantity squared is 4x squared, plus 2 times 2x times 1 is 4x, plus 1 squared is 1, right?
How do you get 14x?
Because I'm squaring, if I want to square out the quantity 2x plus 1 squared, think what this pattern means. The first term, a plus b squared is the first term squared plus 2 times the product of the first and the second, plus the second term squared. Well, my first term is 2x, right?
Okay.
So what would happen if I square out 2x squared? What's that? 4x squared. Right?
Where'd you get the 4x?
Oh, because 2 times a times b. 2 times 2x times 1.
That's fine.
Okay? So to which side do I want to push everything then?
Whatever you
To the left.
Well, I mean, we
Correct,
could, but
correct.
wouldn't it be easier to the right? Because we want a positive number of x squared. So if we push everything to the right, I'm going to get how many x squared?
2.
2x squared. I'm going to subtract 14x,
You get negative 10x
and I'm going to subtract 49,
minus 48.
and that's all going to equal 0. Well, let's put the 0 on the right. Okay? Now what?
My handwriting's
I mean, I guess we could solve
Okay,
it.
so we want to hopefully be able to factor it.
Divide by 2 first.
Okay, good. I can factor out a greatest common factor of 2, right?
Oh, even.
But if it's a greatest common factor of 2, 2 is just a constant. Same thing as just dividing by 2 in this case. Right? We want to simplify both sides. So if I divide each side by 2, same as factoring out a 2 and dividing by 2, I get x squared
Oh,
minus 5x
Minus 24.
minus 24 equals 0. Okay, does that factor?
Yeah,
Yeah.
negative 8 and 3.
-8 and +3, right? Good. So then what are my zeros going to be on this one? What are my solutions?
8,
And -3.
and that means the answer is 8. I keep it 8.
Okay, so those are both good?
Yeah. And that well, not good, but like they're correct
You
answers,
can't
but
use negative.
yeah.
But I can't use -3 because it represents a dimension of a triangle, doesn't it?
Yes.
So this one, we have to get rid of, okay? And we can keep the 8, and does it want dimensions? Yeah, so dimensions, and if I plug 8 in for all my dimensions, what am I going to get?
The base is 8.
The
Uh,
hypotenuse is
Medium
17,
one is
8.
15.
15,
15 and 17,
That was
Okay.
fine.
good? Okay,
That's what we should do. it for.
let's try, that's a good one. Okay, so why don't you turn to your partner here, you can get groups of 2 or 3 just right around you. Talk about this one, see if you can come up with a strategy.
I say let's solve it. Let's multiply 8 plus 6 times
So this is on the second page, I think, top, middle, second page.
times that. I don't know. Oh, yeah, physics perspective.
Are we doing it or just discussing?
Well, I mean, see if you can start doing it at least.
why we're out of hand sanitizer in the school.
Hand sanitizer definitely.
No, it's not true.
Well,
It doesn't, it does, it's, in fact, the coronavirus has a fatty envelope around it, and it actually, like, it's really easy to kill. If you, with alcohol or soap, so like if you wash your hands, hammered, it instantly just explodes
but
your
it has
membrane.
to actually work.
You know what's really
Yeah.
sad?
Right, you have to get the soap in contact with it, or get the alcohol in contact.
I thought you had to use alcohol.
Hmm?
I thought you used alcohol.
No.
Oh, so we gotta have to.
Oh, yeah.
For Davis Law, because Davis was saying,
Oh, yeah.
there's
So if it's like super dry, then the coronavirus would just go away.
No, doesn't work that way.
Oh,
Yeah.
I was feeling good.
It's an interesting question, but no. That's not a way to cure yourself. Okay, so here, real quick, kind of make sure we're getting on the right track. Does anybody have just an overarching general strategy here for finding the shaded area?
Find the area of the outside, then find the area of the inside, and then subtract.
Ah, okay, good. Area by subtraction, right? Would you agree that the shaded gray area is the area of the big rectangle minus the area of the small rectangle? Ah, okay, right? So that makes this easier to do, right? So we'd say then that, let's turn that into an equation. The shaded area is the large area minus the small area. So what's the large area?
X plus 6 times 2x minus 1.
Everybody agree that's the large area?
Z
Okay. Minus the small area
minus x plus 3 times x
equals,
equals
59. right? Okay, that's no big deal. We can do that.
Yes, you can.
Right.
Which mark is it? Well, it's supposed to be.
Okay. I tell you what, let's even, do you think you would want to do this one, or are you okay just knowing that we could expand this out?
I'm okay just knowing that we could.
What would the steps be? I don't want to take up, expand everything out, distribute, collect like terms. We want to put it into standard form, don't we?
Yeah.
We want to make it a quadratic equation in standard form, and then we can solve it using the most convenient method, right? And we've got a lot of practice on
That's
that.
okay. That's good.
Okay, so let's try this one.
that's the Roch's killing my throat.
Let's try another one.
My two consecutive odd is that three times the large.
Oh, these ones are.
These ones are confusing. I feel like drawing a number line for these
Okay, so the first step with any word problem, and that's leading into like physics class and calculus class where we do some big word problems. First step is don't panic. Just read it several times and just get through that stage where you're going, oh my gosh, this isn't your words and I'm at. You just gotta kind of get beyond that and allow yourself to digest this a little bit. You got a suggestion, George?
No, I have a question. What is consecutive?
Okay, what does consecutive mean?
Like,
In order.
In a row.
Okay.
So give me an example of two consecutive positive odd integers.
3 and 5.
3 and 5, okay? 19 and 21, something like that, right? Okay?
Wait, hold on. Positive odd integers.
Mhm.
So it is not negative.
Can't be negative.
Can't be a negative.
That's the odd. That's the odd.
Odd.
Okay.
I don't know why that.
Well, it almost sounds like they're saying positive, negative or something at first, right? Because odd, sometimes, for some reason we associate, I know what you're saying.
Odd
I know why that
equals
looked odd to you.
negative
No
equals.
pun intended.
Oh, wait, 8's not off.
What?
Oh, I got it. Yeah, I didn't know it.
Okay,
No, it doesn't have to be.
and more important than the answer, I want to know how do we get an answer here?
Number line.
No, we don't want to. What we want to do, we want to set this up using algebra, because this is where algebra shines. Algebra is good at, if we're trying to solve for something that's an unknown, algebra allows us to set up equations that provide us an avenue to a solution, right?
Mrs. Jones had us do this last year, but she never gave us like an equation to help us do it. So we had to like sketch and check.
No, we didn't.
Oh, wait,
Well-
there's a visual problem.
Okay, so, hey, let's cut the chatter here. I want to get together on this. So, now, let's have this quick discussion. Why is guess and check really not a good?
It takes a lot of time.
Okay, in fact, it takes not only a lot of time, it could potentially take an infinite amount of time, right? Because what if the answer was the square root of 17? Is that a number you're gonna try? No, it's not a number you're ever gonna try, right? You can have, using algebra, you can come to a solution directly, take a direct path to a solution, regardless of how complicated the solution is. Guess and check is only gonna be something that's applicable if the answer is something that falls into a simple set, like integers, right? I mean, otherwise you're never gonna find it. Because there are an infinite number of possible answers to guess from, right? Okay, so we want to use algebra here. Let's see if we can come up with a solution using algebra. So what about this? Two consecutive positive odd integers. We should always try to define our variables first.
So you have x and x plus 2.
Okay, good. We have x and x plus 2 are our two numbers, right? Why don't we want to use x and y?
Because you want to make sure they're both odd.
Okay, they got to both be odd, and the other, which is good answer. The other thing is we want to introduce as few variables as possible. Introducing extra variables makes it more complicated as a
Why is
system.
it X?
Because if they're, makes sense? Okay. All right, so now let's see if we can turn all this other stuff into an equation that's going to allow us to solve for the value of x, and therefore I'll know both of the numbers, right? The square of the smaller integer added to 3 times the larger integer is 24. Okay, so how can I take this, the square of the smaller integer?
X squared.
So that's going to be x squared added to 3 times the larger integer.
Times X.
Okay, so plus 3 times x plus 2 is 24. How do I say that? Is 24,
Equals 24.
right? No big deal. Okay, so let's see what we get here then. See what the math gods give us. And really, we're just petitioning the math gods for an answer. They're going to give it to us through algebra. So what do we get if we expand all this stuff out? X squared.
X plus 3x plus 6 equals 24.
Okay, so what do I need to do? Good, put it in standard form. Got to get it set equal to 0. So x squared plus 3x minus 18 equals 0. Okay, so how am I going to solve this quadratic equation in standard form? Factoring. It's easy to factor, so we definitely want to do that.
6 and negative 3.
So my magic numbers are positive 6 and negative 3, so what are my solutions?
Negative 6 and positive 3.
Negative 6 and,
Positive 3. Or positive 3.
okay, so what's the answer then? What are the positive odd integers?
3 and 5.
3 and 5, okay.
How'd you get that?
Because that
Right.
has to be positive.
Okay, so were there other numbers that could have worked? Yeah, the math gods told us there were some other numbers that could have worked. They would have been negative 6 and negative 4, but they don't fit the criteria that we established, right?
Could you do 1 and 3? Like without doing that?
No, we couldn't, and how come?
It wouldn't equal.
It wouldn't equal 24, but how, I know what your question is. Your question is, well, x is 3, and there are 2 consecutive odd integers. Why couldn't it be 1 and 3 instead of 3 and 5? The answer is because we defined the first one as x. So the second one has to be x plus 2. Okay?
Right.
So why did the math gods give us this extra information?
Because they're nice.
Well, because it's not their fault. It's our fault, right? It's not really anybody's fault, but the reason they did is because we were not specific enough. When we set up this equation, we didn't say anything about positive odd. We just said solve for x, right? So we have to take the answers they gave us and apply those to the original criteria to see which one fits our restrictions, right? So we'd only pick this one. But negative 6 and negative 4 work, don't they? We could prove it. the square of the smaller. Well, the smaller is -6, right? Smaller means lesser, right? So we get -6 squared is 36, plus 3 times -4 is gonna give us, did I get that wrong? So we're getting, oh yeah, 36 plus -12 is 24, yep, right?
Wait, well, you said smaller is lesser.
It is, right, so -6 is lesser, right?
Well, I was gonna say, but like, Ethan's smaller than Jim, but no offense, Jim, but I think Ethan's smaller.
So, but you get my point, lesser means further to the left on a number line. Okay?
Were
All
you
right.
trying to make a good joke? You failed.
Nah. Okay, here we go, how about this one? How about this one?
Holy crap, no.
Yeah.
Good effort.
Okay, there's a really, this has got a really interesting solution. I mean, I know it will, just knowing the physics will do this, we have an interesting solution. So we're given, here's an example of a quadratic, listen please, too much talking. We got an example of a quadratic model here, okay? So this is telling us, this is the height of a penny above the ground as a function of time, okay? So T is measured in seconds and H is measured in feet. If I drop a penny off the Empire State Building, which is 1,250 feet tall, this is modeling its height, okay? So we want to know how long it would take the penny to strike a 6-foot tall person. Okay, so how could I come up with an equation that would allow me to solve this? Okay, so the height, which is given by this function, is equal to what? What do we want to know? We want to know the time when it, here, let's just, we're not going to get, we're out here at 10, right?
Yeah.
Okay, so we're not going to get through this whole thing, but let's at least get comfortable with the model for a second. So let's take this H of T model. Let's evaluate this at okay, so let's evaluate this at a couple of values of T. What if I plug in 0? What do I get?
0.
Okay, does that make sense?
Yes.
How come?
Because
Okay, so here I am dropping the penny off the Empire State Building. What does times 0 mean? You have no idea. That's when I start to stop, right as soon as I drop it. So the instant I drop it, what's its height going to be?
The very peak.
1250, right? Okay, now what's it going to be? Let's wait for 5 seconds. So H of 5 is going to equal -16 times 5 squared plus, well, let's just make it easy. Let's make it 2 seconds. Let's make it 2 seconds. So that's telling us H of 2 equals -16 times 2 squared plus 1250. Well, I can do the math. That's 4, right?
Yeah.
4 times 16, 64. So I'm getting -64 plus 1250 equals 186. You get the idea?
Yeah.
Okay, we'll pick this up tomorrow.